Today we're talking about complex numbers, also called imaginary numbers. But before we talk about those, we're going to review square root properties. So when I look at these two rules, what they tell me is if I have two numbers multiplied together, I can separate them into two different square roots. Or if I have two numbers divided, I can separate those into two different square roots. An example of this would be the square root of 24. That's one number, but I think about what two numbers multiply to give me a 24. And when I think about that, I have to think about what perfect square divides into 24. So I come up with two answers. So I end up with two square roots. 4 times 6. 4 is a perfect square. The square root of 4 becomes 2, and the square root of 6 stays the square root of 6. So my answer is 2 square roots of 6. The same thing is true with number 2 if I have a fraction under the square root. Let's say I have 1/4 under my square root. I can write that as the square root of 1 over the square root of 4. And the square root of 1 is a 1, and the square root of 4 is 2. So the square root of 1/4 becomes 1/2. So let's practice. We're going to start by simplifying the square root of 50. I have to think to myself, what two perfect squares, or what one perfect square, goes into 50? So if I check my list, or if I think about the list of perfect squares, the one that goes into 50 or divides evenly into 50 is the square root of 25 times the square root of 2. Notice that I write down the two factors of 50. A 25 times 2 is still 50. I still have the same work as the original problem. I just split it up into two numbers. Then the square root of 25 becomes a 5, and the square root of 2 stays the square root of 2. In part B, I look at my two numbers, and I can split them up into two square roots, the square root of 11 over the square root of 49. The square root of 11 is not a perfect square, and there are no perfect squares that go into it. As a matter of fact, it's a prime number. So the numerator is going to stay the square root of 11. But the denominator is a perfect square. Its perfect square is 7, so my answer becomes the square root of 11 over 7. We're going to do the same thing for part C. The square root of 45 is not a perfect square, but I need to think about what perfect square divides into 45. That's the square root of 9 and the square root of 5. The square root of 9 is a perfect square, and it becomes a 3. The square root of 5 stays the square root of 5. We're going to do the same thing with D. We're going to split it up into two square roots, the square root of 32 over the square root of 81. So let's think about this. We're going to start with the denominator. What's the square root of 81? If you said 9, you're correct. In the numerator, the square root of 32 is not a perfect square, but we can reduce it. It is divisible by other perfect squares. What one perfect square goes into the square root of 32? Did you guess the square root of 16 times the square root of 2? Those are the two I would have guessed. The square root of 16 is a perfect square, which becomes a 4, and the square root of 2 stays the same. And my denominator is still the 9 from previously. So that's our review of finding square roots. Now, before we go on to complex numbers, the one question that I want to ask you, which isn't on this page, is what's the square root of a negative 3? If you recall from working with square roots, there is no solution. In previous problems in previous classes, we wrote no solution. Because there isn't a number that when we multiply it by itself gives us a negative. We can't take a negative square root. There can't be negatives in our square root because they don't exist. So we have always thought of it as no solution. Today, however, we're going to come up with a different answer. We're going to talk about imaginary numbers. They are square roots of a negative number, or I. That's what I represents as imaginary numbers. So when I have the square root of a negative 1, it equals I. When I have I squared, it equals a negative 1. So we're going to practice. The first thing we're going to do is we're going to think about that 18, the square root of 18. What perfect square goes into 18? Did you guess 9? So did I. So I'm going to write it as the square root of 9 and the square root of 2. But 9 times 2 gives me a positive 18. So I also need to write the square root of negative 1. Okay? Now, our problem is similar to what we've done before and what you've always known what to do with square roots. But the difference is the square root of negative 1. The square root of negative 1 is going to change things. We know the square root of negative 1 from the previous slide to be I. So I becomes part of my answer. That cancels out the negative 1. The square root of 9 becomes a 3. And the square root of 2 stays the same. I'm going to write part B in a little bit different order to make it less confusing. We're going to go through the same steps. I'm first going to write the square root of a negative 1 because that's going to take care of my negative 125. Then I'm going to figure out what perfect squares go into 125. So I know that that's the square root of 25 and that's the square root of 5 because 25 times 5 is 125. And then I have to work with my variable, which is an x to the 5th. X to the 5th is not a perfect square, so I also need to break up my x to the 5th. I'm going to make it a square root of x to the 4th times the square root of x. How did I get that? Well, because that has a 1 on it. 4 plus 1 is 5. The square root of 4 is a perfect square, which would get rid of part of it. I'm reducing it, but the square root of x stays there. So now we're going to simplify. A couple of things about writing our imaginary numbers. The real numbers go first. So that means I'm going to start with the square root of 25, which is a 5. Followed by the square root of x to the 4th, which is x squared, because an x squared times an x squared is x to the 4th. And then I'm going to do my imaginary number, which is I. And what I am left with is the square root of 5 and x. Those two values still stayed under the square root. We're going to move on to part C and do the same thing. It's a little less complex because it doesn't have a variable in it. I'm going to write 3 square roots. The first one goes in negative 1 to take care of our negative sign. 27, I need a perfect square that goes into 27. What do you think? If you guessed a 9, you would be correct. 9 times 3 is 27. So again, I write my whole number first. The square root of 9 becomes a 3. The square root of a negative 1 becomes an I, and the square root of 3 stays the square root of 3. Now to our last problem. We're going to break it up again. I'm going to end up with the negative 1 to take care of our negative. I need a perfect square that goes into 216. To help you out, I'm going to give you a hint. It's 36. 36 times 6, and then I've got the square root of y to the 4th. Why could I leave it y to the 4th? Why didn't I have to change it? Because 4 is a perfect square. Over here, 5 is not a perfect square. That's why we had to change to 5, but 4 is a perfect square. So we're going to write down, starting with our square root of 36, which is 6, followed by our square root of y to the 4th, which is y squared, followed by our imaginary number, which is I, and then the square root of 6, which remains in our square root sign. Hopefully you aren't too confused because we're going to move on and do something different. We're still working with our imaginary numbers, but now we're there in a different form. So we're going to start out with part A. Part A, if you notice, asks us to multiply. So what we're going to do is we're going to multiply our whole numbers together. So a negative 2 times 7, which gives us a negative 14. And we're going to multiply our imaginary numbers together, which is I times I, or I squared. If you remember from a few slides ago, I squared is really what number? If you said negative 1, you'd be correct. So we're going to write negative 14 times negative 1, because our I squared becomes a negative 1. And a negative 14 multiplied by negative 1 is a positive 14. So my answer for A is positive 14. Part B is a little bit more difficult. So we're going to kind of write some side notes. So here's what I want you to think about. In the previous slide, we had I, which equaled the square root of a -1. I squared, which equals just -1. But then we need another couple of other things. I cubed equals -I, and I to the 4th equals 1. So this is our set, and it follows in this pattern. So if I were to repeat, I to the 5th would be the square root of a -1. I to the 6th would be -1. I to the 7th would be this -I. And I to the 8th would be 1. And if I were to go through it again, I to the 9th would be the square root of -1. I to the 10th would be -1. I to the 11th would be -I. And I to the 12th would be 1. So in other words, with every power of 4, my answer is 1. So I'm going to work on this information right here. All right, I have that to the 45th. So I'm going to change my answer, or change my question, so that this number is divisible by 4. I'm going to change it to I to the 44th times I to the 1st. Since this one is divisible by 4, 44 is divisible by 4, that answer just becomes the number 1 times I to the 1st, which is just I. So when I simplify for my actual answer becomes 1 times I, or just I. So I to the 45th is equal to I. Part C. In Part C, we have to take care of our negative numbers first. So the first thing we're going to do is we're going to write the -1 times the square root of 10 times the square root of a -1 times the square root of 15. So the first thing we're going to do is we're going to multiply our two, or we're actually going to change our square roots of 1 to i's. So this is I square roots of 10 times I square roots of 15. All right, to finish this problem, I multiply. I end up with I squared times the square root of 150. Okay? Of course, from previous information, from previous knowledge, we know that I squared becomes a -1, and the square root of 150 becomes the square root of 25 and the square root of 6. Or that's -1 times 5 times the square root of 6, or a -5 square roots of 6 as our final answer. We're going to do the same thing in D. We're going to take care of our negatives first. So it's -1 under the square root times 20 times the square root of -1 times the square root of 12. This becomes I square roots of 20 times I square roots of 12. Or it becomes I squared times the square root of 240. I squared becomes a -1. And I'm going to break 240 into one perfect square and another number. That's the square root of 16 and the square root of 15. So it simplifies to -1 times 4 times the square root of 15, or just a -4 square roots of 15. For our last slide, we have to solve, and we're going to solve using imaginary numbers as well. So we're going to start with A. In order for us to solve for x, the very first thing we're going to do is we're going to subtract 48 on both sides. So we end up with 3x squared equals a -48. The next thing we're going to do is we're going to divide both sides by 3. We end up with x squared equals a -16. To get rid of the squared part, we square root both sides of our equation, and we end up with x equals the square root of a -16. So we have to use our imaginary numbers. So we end up with x equals the square root of -1 times the square root of 16. Or that becomes x equals 4i. I'm going to zoom in so we have a little bit more room. B, we're going to do the same. We're going to subtract 100 on both the left and the right. 4x squared equals a -100. Divide both sides by 4. X squared equals a -25. Square root both the left and the right. X equals the square root of -25. But that becomes the square root of negative 1 and the square root of a positive 25, which equals, the square root of 25, of course, is a 5, and the square root of negative 1 is I. Simplified. Last one. We're going to subtract 4 on both the left and the right. X squared equals a negative 4. Square root, both sides, x equals the square root of a negative 4. We have to simplify that into the square root of negative 1 and the square root of 4, which becomes 2i for our answer. Here's your homework assignment. Good luck, and we'll go over questions tomorrow.